Hello, everyone. I'm Rick Anthony. I'm the General Manager of the Amazon Inspector Service. I'm very pleased to be here today to talk to you about vulnerability management at scale and talk about how that can drive enterprise transformation. I have Brandon Stevens with me, and he'll be talking a little later. So our agenda today, we're going to talk about Amazon Inspector. What problems does Inspector solve? How does it work? What are some of the recent announcements and features that we've launched? And then we're going to jump over to Brandon, who's going to talk about Next Gen and their journey with Amazon Inspector. And then we're going to finish off with a demo and give everyone a chance to ask questions. Okay, so what is Amazon Inspector? If you Google Inspector, you'll end up actually with two results. You're going to see a product called Inspector Classic, and that is a product that we launched back in 2015. That is also a vulnerability management tool. We're not going to be talking about that today. We're going to be talking about the new Amazon Inspector that we launched at reInvent in 2021. I would say the big difference between the two is that Amazon Classic, Inspector Classic, was more of a tool, and it worked like a vulnerability management tool where, as a user, you had to tell Inspector what to scan, when to scan, and then it was up to you to take the results and figure out what you want to do with them. In contrast to that, the new Amazon Inspector is a vulnerability management service. And what we mean by that is this is a service that tries to unload the responsibility of having to figure out what to scan, when to scan. It wants to take care of that for you. And this is a product that will continually scan all of your workloads for software vulnerabilities and unintended network exposures. And today we support three types of workloads. Workloads on EC2 instances, workloads that are serverless running through Lambda, and workloads on containers where you're using images stored in Amazon ECR. So when we went to create the new Amazon Inspector, we went out and we talked to customers, and we really just said, hey, what problems are you trying to solve? What are some of the things that the traditional VM tools just are not doing for you? And some of the things that customers told us is, number one, they want products that are built for the cloud. And what we know about the cloud is it's very flexible, very fast. As a user, you can very easily spin up resources, terminate resources, scale at will. I mean, that's part of the value of the cloud. And the challenge with vulnerability management is if you're only periodically scanning, how do you capture those resources? How do you know what happens in your environment when you're not looking? The second challenge that customers told us is that sometimes these tools are really hard to use, and as a result, they don't use them that often, and that creates gaps in their visibility, and they really want to deal with vulnerabilities in as near real time as possible. If you think about Log4j, which was a very famous vulnerability that happened, December of 2021, that was a vulnerability where you wanted to know what your exposure was as soon as possible. You didn't want to have to wait for your teams to scan to figure out where you needed to do remediations. The third thing customers told us is that while they have workloads that are on different environments and compute types, they're typically promoting their resources from EC2 to containers, and some customers are even migrating their container apps over to serverless. They don't want to use different tools just to know what the vulnerabilities are in their app just because the underlying resource changed. They want one tool that will really serve all their needs. And number four, they wanted an easy way to take the data out of the tool and do something meaningful with it. They wanted to be able to put it into another tool so that they could either ticket their owner, the developer who owns that application, and say, fix this, or they wanted to try to create some type of automated patching tool. So getting the data out easily was a core requirement for Inspector. So how did we look at those problems and decide how to address them? Well, essentially, we really focused on three core areas to try to meet those needs. Number one, we wanted the enablement and configuration process to be as simple as possible so that as a user, there was just no friction in order to turn on Inspector and get value out of it right away. Number two, we wanted to have a product that wouldn't have gaps in visibility. So we wanted to create something that would just continually look at your environment, and as soon as a change occurred, it would detect it and it would scan for you so that as a user, you didn't have to worry about the scanning. All you had to worry about was the resulting data and worried about your remediation. And number three, we wanted to help customers deal with the really large volumes of findings that can come out of VM systems. And so there are a lot of vulnerabilities out there. And if you ever scan an older EC2 instance, you will see right away you could have easily tens, if not hundreds of findings. How do you know which ones are really the important ones for your environment? And so we wanted to create a way where, as a user, you could see a risk score that would say, okay, this is likely, for you, the most important vulnerability to deal with right now. So diving into those, so we talked about number one, that frictionless activation. So we will show this in the demo later today, but to turn on Inspector, it is literally a single click within our console. And if you are a company that uses AWS organizations and manage your accounts through that organization, we allow you to create or designate a delegated administrator account. And the power of that is now you have a single account that controls your entire organization and controls both the enablement and configuration of Inspector, so that not only are you turning on Inspector with one click for your account, you're almost turning it on for your entire organization with just a handful of clicks. And we provide capabilities where you can tell Inspector, oh, and by the way, not only turn it on for my organization, but as new accounts are added, automatically turn it on for them so that there's no gaps in my visibility. You don't have to wait for someone to remember to turn it on and get that coverage. So what this results in is an easy way to turn on Inspector, and you really get security by default, because when you enable it, we turn everything on. We give you 15 free days to evaluate, and for things that aren't useful, you just turn those things off and keep the other things on. Number two, the continual vulnerability monitoring aspect. When you turn on Inspector, it goes through a number of phases. Number one, it looks at your environment and it catalogs all of your assets. So it will look at all your EC2 instances. It will look at all of your container repos and container images stored in ECR. And it will look at all your serverless functions that are in Lambda. And so now, as a security team, you have visibility into all the resources that are out there. You don't have to guess. You don't have any blind spots. You see everything that exists. Once we catalog and do that asset discovery, we then go through and do an assessment of all those resources in order to get a baseline of what's in your environment. And from that point forward, we just monitor. And we use algorithms to intelligently know what to do next. So as an example, once you have Inspector turned on and it assesses everything, if you launch a new EC2 instance, Inspector goes out and does an assessment and gives you findings in near real time. The data is just there. If you go and you patch a EC2 instance to bring it up to date and that remediates vulnerabilities, Inspector also detects that. It will go through, find the findings that it generated to tell you about the vulnerability, and automatically close them. So you're not trying to take data from multiple assessment runs and sew them together to figure out where you're at. Every time you log into Inspector, you know this is the current state of my environment. So the third way we also do deltas is if there is a brand new CVE definition. So for example, let's say a brand new log4j hits tomorrow. As a user of Inspector, as soon as we receive the definition of that vulnerability, it gets ingested into Inspector. We automatically look at all the resources and decide, okay, which of these are impacted, and Inspector will reassess those automatically. So as a user, you can go in and say, okay, what are my results? I don't have to do a scan. I don't have to wait for them to finish. They just happen in the background automatically. So earlier today, I gave a very similar talk, and we partnered with Volkswagen Financial Services, and they are also a user of Inspector. And the reason I'm mentioning them is because I think they had a very powerful example of how this worked well for them. So we talked about Log4j, but there was also a very serious set of vulnerabilities that were 0-day for Microsoft in March of 2023. And the speaker who I was working with and talking to earlier today, he showed that when that became known, he got a call because he owns a vulnerability management program. And essentially his director said, are we impacted? And he said, okay, give me a couple minutes. And within 16 minutes, he knew the entirety of the impact across 15,000 accounts. Within 16 minutes, he was able to give his director an answer. This is exactly where we are impacted. And within 74 minutes, they had tickets out to all those owners to begin the remediation process. So that kind of shows you the power of how quickly having that near real-time data really can be. He had said if they had to do a traditional vulnerability scan, it would have taken them days just to get the data to kind of even know what was impacted. And then finally, the prioritization. So once we do create a finding, we need to tell you how serious is that finding. Is this critical? Is this really, really critical? Or is this something maybe you can wait a little while? So within your environment, we gather a lot of information. Obviously, we have the severity information that we get from our sources, whether that's NVD or whether you're maybe using Amazon Linux and you're getting the severity from the Amazon Linux team or Red Hat or whoever. We take that and we combine that with information like, is your EC2 instance accessible from the internet? Because if the answer is no, then probably your risk goes down. If that vulnerability doesn't have an exploit that's known in the wild, that may be less important. If it does have one that's known in the wild and that EC2 instance is exposed, that really probably makes that vulnerability much more important. And we do that work for you, and we provide you with an inspector score, so at a glance you can figure out, okay, where do I start? What's the really important thing for me? So that is kind of the state of Inspector, really as it was at the beginning of this year. And this year we've launched a number of new features, two of which I'll talk about a little more in depth, that were announced at this Reinforce. But the first feature I wanted to kind of give a brief introduction to is called Deep Inspection. So within EC2 instances and within container images, we already go in and we take a look at the package manager that the OS runs to pull out the packages and say, okay, you're running OpenSSL version 1.2, let me go see if there's any vulnerabilities and I'll report that to you. But for container images, we actually go a step further. We scan the entire file system and we look for things that we can decompose further. As an example, we look for jar files that make up your Java applications, and we will tear them apart and say, okay, well, what are the dependencies that were built into this jar file? Do those dependencies have any vulnerabilities you should be aware of? If we see Golang binaries, we do the same thing. We tear them apart. If we see Python applications, Node applications, we do that. And we're able to do that through the entire container image because usually they're on the smaller side. So scanning through all that is really typically not that big of a deal. We never did that in the past for EC2, but we just announced a feature called Deep Inspection where we will do that. However, we don't do it for the entire file system. As a user, you can choose where you want us to do that deep inspection. So maybe your development team stores all their applications in a specific directory. You can specify that to Inspector. It will look more deeply into that directory so that now you're getting better coverage of the software that you're putting on those instances. The second thing that we've announced is access to our vulnerability intelligence database. And what we were finding is that we made Inspector almost a little too automatic in that it just goes off and scans. And we got a lot of customer support questions where customers are like, but do you support this new vulnerability? And it was just defined yesterday. Is it in your system? And sure, if they had a resource that was affected, they could see, yes, I have it. But if they weren't, there was no positive indication that, no, we actually cover this and you're fine. And so now we give you the ability to go to a search screen, type in a CVE ID, and we will tell you, do we support the CVE, and for what operating systems or what platforms do we support it? So there's no more guessing as to what we support and what we don't support. Number 3, we've added more information to our findings in terms of exploitability. So we've added what's called the EPSS score, which is the exploitability predictability score. And this is just one more factor that you can use as a customer to know, is this likely going to be exploited? So, does this make this a high criticality for me, or is this a low criticality? And then the final 2, which are software bills of material, export and Lambda code scanning. Let me jump into those next. So a software bill of materials is really just a list of the packages that you have in your resource. So every time you run a workload on EC2, the inventory of that is going to be all of the packages in the operating system package manager, as well as anything we find in deep inspection. So for example, if you have a Java application and we tear it apart, every single Java dependency becomes something that is a Java or a software asset that you should know about. And we now give you the ability to take the data that we now know about and export it into S3, and then do whatever you want with it. You can do Athena queries, you can bring it into other tools, and when you combine this with a delegated administrator, that delegated administrator not only controls your entire organization, it also sees all your data, so it's all in one place. So this gives you the ability to export your software assets in one swoop to S3 to do whatever you want, and I'll show that later today in the demo. And it's really just as easy as giving it an S3 bucket location, giving it a KMS key, and saying what format do you want the data in. And we support 2 standard formats today, Cyclone DX and SPDX, and in the future, we'll support more as well. And then the other launch that we announced was code scanning with Amazon Inspector. And this was something that was already in private preview, and we had some customers kicking the tires for quite a while, and we just announced the general availability. I do want to just spend a very quick minute kind of explaining how this differs from standard scanning, which we already supported. So standard scanning is our native capability where if you have a Lambda function, we will take that Lambda function, tear it apart, and find all of your software dependencies and tell you if there's vulnerabilities related to them. That's standard scanning. Code scanning is looking at the code your developers wrote and see, are there any violations of security best practices? So as an example, we find that sometimes developers, when they're writing test code and they're trying to get things worked out real quickly, they'll hard code a credential, right? Like they kind of, instead of putting the credential in Secret Manager and wiring it up, it's just much easier to put it in the code, test it out, and hopefully they don't forget that, and they don't forget to take it out later. But if they do forget, code scanning will find that and say, hey, you have a credential here, you don't want that in your code, that's not a best practice, and we will provide ways to fix that. Another example might be if your developer writes code where they take something that's encrypted and they decrypt it and then they log it. That's something you probably don't want to do. If it was encrypted, it was sensitive. You do not want to log that sensitive thing that's now in plain text. That's going to be a violation as well. And so now we have 2 aspects of Lambda code security. One is security of all of the dependencies that you're bringing with you, because most code has dependencies on open source. And then number 2, are there vulnerabilities in the code your developers wrote that could be better and stronger? These might be a little hard to see, but these are kind of examples of both of those types of findings. So I'll show this during the demo, but it's very easy to turn on and turn off these features. And then this middle box shows you an example of a standard scanning finding. And so this is simply a package that has a vulnerability that was included in a Lambda, and we're simply saying, okay, you included this package, it looks to be URL-lib, and there's a vulnerability associated with the finding version. There is a fix available, here's the version you need to upgrade to. And then on the other side, here is a code scanning finding. In this case, you have an insecure socket bind. And what this means is you have some type of socket that you're opening to listen for data, but you didn't tie it to an IP address. You simply told the operating system, I don't care what you bind it to. Well, you may care. You want the operating system to bind it to the IP address that is supposed to take the data, not just every single IP address available on your instance. So with that, I do want to turn it over to Brandon to talk about next-gen healthcare journey with Amazon Inspector, and then I'll be back later to show you a demo.
Great. Thanks, Rick. I'm Brandon Stevens. I'm a cloud architect at next-gen healthcare, and my team is responsible for scaling security and compliance across all of our AWS workloads. My team maintains a platform that includes services like Amazon Inspector and our own internally developed applications and services, which you'll hear more about one of them later. At NextGen Healthcare, we're a healthcare technology company. Our primary customers are practices and clinics that provide clinical care to patients like you and me. Our software manages your electronic health record, but also provides those practices the ability to schedule appointments and to be able to bill patients. We offer a variety of products to our customers, and this is just a highlight of some of the products that we have. Our flagship product is an enterprise EHR, that provides, at the core, a clinical care solution. But we also allow our customers to be able to add on ancillary products to meet their specific needs. These are things like financial services, which includes billing, but also patient engagement solutions. They're really able to tailor this enterprise EHR to exactly what they need. But for those smaller practices and offices, we offer an integrated SaaS-based solution that has everything they need, and we provide all that hosting, so they don't have anything to worry about. For both those enterprise and office customers, we have products that give them insights into their data. This ranges from everything from data exchange and interoperability to helping them understand their patient population health. We've been in this industry for decades. And when our AWS journey started over 10 years ago, where we started to use AWS to extend our data centers, providing R&D a place to innovate. And since then, our usage and our AWS footprint rapidly increased. 5 years ago, we decided to go all in. And at that point, we were already hosting most of our workloads in AWS, but we still had a lot of applications running in our data centers. So we started aggressively moving those out of the data centers. And today, we only have a handful left of application and data centers that we still need to migrate into AWS. But that decision of going all in with AWS allows us to take a look at the tooling that we have in place for concerns like vulnerability management and focus on those tools that are cloud native, that are built for AWS, services like Amazon Inspector, that can handle our challenges of using AWS at a large scale with diverse architectures in place. But when we first started using AWS, we maintained our existing tooling. It worked really well in the data center, which was pretty slow moving. We were able to maintain that coverage. We were able to prioritize findings as they came up. But as we used AWS more, our architectures became even more diverse. They became more cloud native, leveraging things like the elasticity of the cloud. it became more and more challenging to maintain that coverage. And for us being a healthcare company, that's non-negotiable. We need to have that coverage in place. We need to be scanning every single thing we're running in AWS. And if there's gaps, that's going to slow down releases, migrations, because we need to have that in place. Then we can see what we need to remediate. And then with those remediation items, it became more challenging, more complex to prioritize those. So again, we're adding friction. We're not able to move as fast as we want to in AWS. But we're also doing it at a much higher cost with engineering. So there's more operational burden, just to maintain that status quo. And you heard Rick talk about, what problems Inspector tries to solve. And I mean, those are all the problems that we had. So we're really excited to be able to start using Inspector, and we really need to, at our scale, we wanted to start slow, really prove it out, but then, if it was successful, ramp it up. So I'm going to talk through in more detail, those challenges we have and how well Inspector did up against those. So talking about agent and scanning coverage, we have this diverse application technology landscape. We have a very large EC2 footprint, and we're continuing to build more and more serverless components and applications, leveraging Lambda and Fargate to host those. And today we have 10,000 compute resources that we need to protect. And on those 10,000 resources, we have a variety of operating systems and programming languages that are running on those. And with the existing tooling, we built up the automation to have that coverage, to make sure we're scanning everything, using things like EC2 image builder components, systems manager documents, the tools that AWS provides for automation. But that wasn't enough. We were finding gaps. We were having to care and feed, that automation. And even then, still having to spend a lot of time, making sure you had that coverage before we could move forward. And it was, this time last year where we started to look at Inspector, but we were also planning a large migration, of an application that we're hosting in a data center that was pretty diverse itself. And we knew that, with this application, we'd run into a lot of the same challenges, especially, with an application that we wanted to make sure we migrated it right. We wanted to, look at what we could re-architect. What could we re-platform, and try and minimize what we're just rehosting, what we're just moving into AWS. So that target AWS architecture for this application, was quite diverse and reflected, the rest of our AWS environments. So, it was that perfect time to, try out Inspector at a pretty good scale and see how well it worked up, against the challenges that we're having with coverage. And Rick was talking about how easy it is to set up, and it's very true. We delegate administration to a dedicated account so we can manage Inspector, from one spot across our 150 accounts. We're able to go in, and select the handful of accounts that were part of this migration scope and enable it with just a few clicks. And we did this while we had already started some of that migration effort. We're doing a lot of development, building out infrastructure, replacing it, and just with those few clicks, over 90% coverage of the servers we have in place, far more than we expected, if we were continuing to use the previous software we had in place. 100% of our Lambda functions, all that work we put into re-architecture, we had the scanning coverage right out of the box. And the gaps that we had, they weren't directly related to Inspector. They were part of some of the servers that were lifting and shifting. And we were still doing the development and migration work. And we missed some stuff with IAM, things related to Systems Manager, which Inspector leverages. With Systems Manager already being a foundation of how we do operations, how we do remote access, how we do patch management. These were things we caught early and we were able to fix, not just so we have those tools in place, but also so that we have, Inspector works. And we were able to get, almost everything working in Spectre with minimal effort. And we just ran into a couple servers, some legacy backend servers. They don't process patient data or personal data, but they're running on older OSs, and it would have taken significant effort to be able to modernize them. So we looked at all of that, and we made the decision. We were continuing forward with the migration, knowing that we would have to address that, detect it later. And we've already begun that process. So the coverage, the agent coverage, the scanning coverage, was phenomenal, with this workload that we're migrating into AWS. But the other concern we're having is, around prioritization, and not just with vulnerabilities themselves, but across multiple tools that we have in place. We have tools running, against our source code. We have tools running against our AWS infrastructure looking for, non-compliant or, looking at configuration changes. But all of those, at the time, were in separate tools. So, our security analysts or the security champions on, in our development teams, they're having to, keep track of vulnerabilities across multiple tools and really try and figure out, what is the most important thing to work on? Is this something that's absolutely critical that we need to fix today, or is it something that can be prioritized in backlogs? So we have the vulnerability manager separate, we had source code scanning separate, but we had everything else aggregated in Security Hub, and that was working really well for us. So we were seeing things from guard duty, we were seeing things from Shield Advanced for DDoS protection. All of that was being aggregated in Security Hub, and we're seeing a lot of success with being able to remediate any of the findings that were coming up. And it's not just aggregating across those sources, but aggregating across regions and accounts. So we do have a single place, single pane of glass where our security teams are able to understand the security posture across all of our AWS accounts. So what we were left with, we could use the existing software, but if we wanted to integrate that into Security Hub, that's a lot of engineering that we have to do, another thing we have to maintain that needs care and feeding. Or we can just use Inspector. Inspector natively integrates into Security Hub, so when we flip that switch and enable it during the migration, we were already getting that information in Security Hub, and we were able to use that to be able to understand the security posture of the infrastructure we're building out in the AWS. And that's really powerful. But in addition to that, we're able to easily extend Security Hub with things like Amazon QuickSight to give us more advanced reporting, as well as enhanced alerting with an internal service we developed called GOAT. And all that integrates into one place, one region for Security Hub, and we're able to really extend what Security Hub already provides. So this migration, it was a really large migration, and it went on over months. Plenty of time for new critical vulnerabilities to come up, things that we had to jump on and remediate as soon as possible. And Inspector was just telling us about those in real time. They were being published to Security Hub, which was triggering GOAT, our internal alerting tool, and notifying the people, the right people who can fix that stuff, and giving them the most relevant information that they need to make the decision on what they need to do. So multiple times throughout this migration, we were seeing vulnerabilities remediated in hours. Those engineers responsible for remediation, had the information, in real time, and were able to trigger things like EC2 image builder pipelines, or use Patch Manager to patch the instances. And being able to coordinate that through across our fleet, does not impact migration work, but we're still seeing that done in hours and without involving any other teams. And that was one of the challenges we were having with the third-party software we were using previously. We have multiple people, multiple teams involved, and anytime you have that, you're going to have latency, you're going to have delays, and things are going to take days. The security analyst is out or working on the West Coast, and so you don't have those handoffs as quickly as you'd like. And you can, of course, accelerate that. When things are really serious, like Log4j, you jump on it, but you can't have every single vulnerability be a fire drill. That's not sustainable. And Inspector allows us to have the same sort of low mean time to remediation, but without that effort and that chaos that those fire drills can have. So we were seeing even better remediation. That was not something we expected, but something that was really a big compelling benefit to using Inspector at our scale. And I wanted to touch on that internal service we have called GOAT, because this is something that not just for Inspector now, but for a lot of the other, not just security findings, but operational concerns that are critical to the people that are working in AWS. This facilitates how we get that to the teams and how we're able to give them the relevant information that they need to be able to easily remediate or react to the events. So we hook into Security Hub, we hook into AWS Health, we hook into those services using EventBridge. So as Inspector detects a vulnerability, publishes that to Security Hub, GOAT is triggered and it's able to start doing its work. And one of the big things it does is it pulls in other information. It enriches what comes from Inspector or Security Hub, looks at the AWS account, pulls information off the account tags, and helps us understand, what is the workload? What is the environment type? Is it a production environment? Is it a sandbox environment? And also looks at the resource. What is the component? Is it publicly accessible? What's the data classification? Is there PHI or sensitive data in it, or is it a public data set? So it pulls that information in. It references internal knowledge base, for common runbooks, so we can provide teams with that prescriptive guidance on what to do for that type of finding. It pulls all that in. It takes information it gets from the source and presents it so that team has all the right information at their fingertips. So they know, ultimately what is the risk of this finding given where it occurred. And then for things like Inspector, it'll tell them, is there an exploit available? Is there a fix available? Things that they need to know to take those next steps. One other important thing it does too is it handles all that plumbing to our channels. We have, like I said, 150 accounts. We have dozens of channels that different operation teams use for critical alerts. So we want to make sure that all that plumbing works as our AWS accounts grow, as our operations teams grow. This handles all of that connectivity between alerts in AWS that GOAT gets and the channels that we need to notify teams at. So we've been thrilled with Inspector. We've been able to maintain that coverage with less effort. We're being able to remediate findings quicker than we could before. And we've continued rolling out Inspector as aggressively as we could. And we're still continuing to roll it out, hoping to finish up later this summer. With code scanning going GA, we're excited to start leveraging that more and more. We've started rolling that out to our environments as well. Another thing we really want to focus on too is, how can we better leverage Security Hub, as that foundation, for security operations. So GOAT does a lot of enrichment after a finding occurs when we're doing alerting, but if we pull that into Security Hub, that information is always available, for reporting through QuickSight, but also for alerting. And then there's other things we can do, like with the Security Hub automation rules. That's an announcement I was really excited to hear about because we could start leveraging that to start taking that enrichment data maybe change the severity, either increase it or decrease it based off of that context. If it's a sandbox, maybe we drop it or maybe we leave it the same. But if it's a critical environment, that has high risk to us, maybe that high finding really is critical. And then we can also look at, as we get these findings in, if we know there's a fix available, we can kick off that patching process right away. If it's creating a new AMI through EC2 Image Builder, we can kick that off so that when the operations teams get engaged, they just need to wait for that to complete before they roll it out to their fleet of instances. And then also kind of looking at what are the other ways we can leverage Security Hub. So we have tooling for source code scanning, that continues to be separate. Can we get the same benefits that Inspector provides us, if we're able to integrate into the Security Hub as well? Or is there other tooling that provides that for us? And we're always looking at ways that we can improve. And it seems like every single time we do one of these conferences, there's new stuff that comes out that we're really excited for. So I thank everyone for giving me a chance to share my journey. Pass things back to Rick, who is going to be giving you a demo.
Awesome. Thank you. All right. So thank you, Brandon. Just wanted to show you some of the screens within the console of Inspector. We've talked about a lot of capabilities, and just wanted to show you what some of these really look like. So this screen is what you'll see the first time you come into Inspector with an account that is a standalone account, meaning it's not part of an organization. You simply have the ability to activate Inspector. And if you were to click that button, this will turn Inspector on in this region for this account. If this was part of an organization that did not have Inspector already enabled, there would also be a second panel that would allow you to specify a designated administrator if this account was the management account, so that you can, within one click, you would type the delegated admin account number, you would say enable, and that's your single click. Once you do that, Inspector goes through the process that we talked about earlier of looking at your environment across all of the accounts in your org and collecting that inventory and doing an assessment. And once it's done that, it then goes into monitoring mode. And within the console, you can always see what is my coverage. And so you can see here, this is a really small organization that I set up as a demo that has 3 accounts in it, a couple of EC2 instances, a couple of container repos and images, and a couple of Lambda functions. And you can see as of right now, Inspector's enabled on 3 out of 3 accounts. It's enabled, my coverage for EC2 is 8 out of 11, and we'll see why those other 3 are not covered. And of my repos, I am enabled for 2 out of 2, and of my Lambdas, I'm at 100%. And this is all out of the box without me doing anything. Obviously, for EC2, like Brandon talked about, there is a dependency on SSM. And so, if you're a user already utilizing SSM for some of the capabilities of inventory reporting, patching, session management, then it's already set up for you. So if you are an administrator, which this account is, you get the view into everything. If you were just a single account within this organization, you would only see your information. You would not be able to see the information from other accounts. But as that administrator, there's a number of things that I can do. I can go in and across the accounts in my org, I can do different actions. I could turn off some of the scanning. I could turn off EC2 or ECR. I could go in and activate as well. And so with single clicks, you can take actions that impact your entire organization. Once you set up an organization, that delegated administrator has that kind of administrative power. If you are an individual account, you can still turn Inspector on and you can still turn features on, you can't turn them off. You have to go back to the delegated admin. And this is how we prevent gaps from being created. Things can get turned on, turning them off is much harder. As a delegated administrator, I also have the ability to automatically activate Inspector for new accounts, and I can say which things I want turned on. And all of this is powered by AWS organizations. And so as accounts get added, these features get turned on, and that's what keeps your coverage at 100% or as close to 100% as possible. Going back to our dashboard, you can dive in and see the information about your environment coverage to figure out, well, what went wrong? I have 11 EC2 instances. Why are only 8 of those covered? So if I click into that, Inspector will give you information about what it found and why it couldn't cover the instance. So here we have a set of tabs. You can see we have 11 instances. 8 of them we are scanning. And if you were to look at the ones we're scanning, we give you some information as to what's the EC2 instance, what account does it belong to, what AMI was it launched from, what's the operating system, and what's the last time we looked at this EC2 instance. So one of the things I talked about earlier is that Inspector is intelligently scanning for you. As a customer, you don't have to ever say, scan this thing. You just have to turn Inspector on. And if you have an EC2 instance and SSM running in the background, it is constantly pulling inventory and reporting it back. The default interval is 30 minutes. And so we tell you, when was the last time we saw inventory from that EC2 instance to give you an idea of how fresh everything is. In this case, if I look at the not scanning, I see that, okay, there are 3 instances. These are the IDs. I can click through to the individual console for those if I wanted to. These are the AMIs they were launched for. And I don't know what the operating system is. And the reason for that is that these are unmanaged instances. And so Inspector tries to give you guidance as to what went wrong. And in this case, it's not a managed instance. Either SSM is not installed or the IAM policy isn't correct for a managed instance. And it will give you guidance as to how to fix that. Other reasons why it may not be covered, I think in Brandon's example, is an unsupported operating system. So you may have an older operating system we don't support, and we will tell you an unsupported operating system. And you can look at the other types of information as well. So for example, here on the main dashboard, I showed you we had 2 of 2 repositories covered. Here are the details of those repositories, and you can see that the status is that we're continually monitoring those. Within those repos, we have a number of images. Here you can see the details of those as well. And then for Lambda functions, we provide that same information. What is the runtime? What's the function name? What is the runtime? Are we actively monitoring it or not? All of this information that I'm showing you is available via the API and the CLI as well. So while you can always go to the console to see this information, if you want to try to create an automation like the GOAT system that Brandon talked about, you can use the APIs and pull the raw information out and do whatever you want with it. In addition to us making it available via the API, we also publish a ton of the state changes onto EventBridge, so you can do a lot of dynamic programming. Once everything is covered to your satisfaction or as close as you can get, you now have some idea of what the critical findings are within your environment. And you can see in this case, for container images, I have 155 critical findings. We created this demo account, I think a couple of months ago, and we threw those resources in at that time, and that number was much smaller. You know, as software ages, you get more and more vulnerabilities, and that number, I think if I were to give this talk a month from now, I bet that number will be 165 or something larger, just because new vulnerabilities are discovered all the time. Inspector will automatically scan, and that number will go up unless you're remediating and patching. We could zoom in on those 5 critical for Lambda to kind of see some of the details. And in this case, you can see that the top one is a code scan. That's the new capability that we launched here at Reinforce for GA. And this is basically a vulnerability in the code your developer wrote. And then there's a number that are related to the dependencies that the developer pulled in with them. And you can see these are all Python related. JW2 is the JSON Web Token. And so if I were to open that one, you can see here, this is the information available to you. What's the CVE ID? What's the relevant package? What is the description? And then down below, you can get a lot of metadata. And all of this information is also in the finding, which we send to Security Hub. We publish to EventBridge, and you can pull the raw data as well from the APIs. Or you could tell Inspector, hey, export this data for me. And you can specify, well, which findings do you want? Do you want them all? Do you want some subset? And it will write findings to an S3 bucket for you, just like the SBOM example I'll show you in a couple minutes. And in this case, it's telling you that you're running version 3.33 and that you really need version 3.34 to remediate. So, when you provide this information back to your developers, you're telling them exactly what version they need to go to remediate this. If I were to switch over to the code scanning, this is a little different. These are not CVEs. These are violations of security best practice. And this is the sample that we showed in the slides. This is an example of what's called an insecure socket bind. And in this case, this is a critical finding based on the detector called insecure socket bind and the rule. All of these code scanning findings are powered by Code Guru. So we partner with them, and they provide the engine that does all of these checks. And so anytime you see one of these, you can click in, and it'll take you to documentation that you can provide to your developers to help them understand why this is not a best practice and what they can do about it. In this case, a fix is available. This is something that's fixable. And here, it will actually highlight the piece of code that is the problem. In some of these, we will even give you a code patch. This example doesn't have one, but many of the examples have a code patch that the developer can take right then and there and put it in. In this case, there's no way for us to know what IP you wanted to bind to, so it's up to the developer to figure that out. But if it's a matter of logging something, for example, logging something before decrypting, so it's not in plain text, then that's something that the system's easily able to, through ML, give you a good code recommendation. And going back to the dashboard, we kind of showed you just some very high level, hey, here are the criticals. But we found that customers operate in different ways. They have different criteria for what they look for and how they choose to remediate those. So we provide a lot of information, and we roll the data up into different ways so that you can find something that's going to work for you if you decide that you're going to use the Inspector Console and use that as your place of work. So as an example, this first tile is risk-based remediation. And this gives you an idea of, okay, if what one single remediation will get rid of most of the critical vulnerabilities. And in this case, it's essentially Jackson data bind. If you were to resolve that and upgrade to the new version, you would automatically get rid of 26 critical vulnerabilities across your estate. So some customers choose to operate per resource, some choose to operate per account, some choose to operate per vulnerability in order to drive these numbers down. And the rest of the panels are really along those similar veins. Counts with most critical findings, repos with most critical findings, images, container images with critical findings, EC2. So there's really here a panel for however you want to slice and dice the data. Some customers honestly don't even patch their EC2 instances. They work from golden armies. And so for them, they want to know, well, which AMI is the one I have to fix and redeploy. And so we can give you a view into that as well. So the other thing I wanted to show, so that is kind of Inspector in a nutshell. I've kind of showed you how to turn it on, how to evaluate your coverage, how to look at some basic finding details. But I did want to show the other new feature, which was export SBOM. And so the SBOM is really an export of, again, all of the packages and software on your resource exported along with your resource details in a format that's a standard. And once you export it to S3, it's yours. You can do whatever you want with it. I've set up a sample where I've exported it to S3 in advance, and I've written some simple Athena queries just to kind of demonstrate some of the power. But if you wanted to really do this, it would be as simple as saying, okay, I want to export everything. I want it in Cyclone DX format. I'm going to choose one of my buckets to send it to. Maybe I want to send it to this bucket here. And I think my screen's too big. Here we go. Let me do this. Actually, let's pick the export bucket. I could say that's the bucket I want to use. This is the KMS key that I want to encrypt everything with and export. And once you click that, a job will start and a banner will show up saying your job's in progress. And when your job finishes, it will tell you. Today, you can only do one export at a time. And in the future, you'll probably be able to schedule these exports versus having to do them one-off. Again, because it's driven by APIs, you could automate this in any way you really want. And once you do have an export that is done, you'll end up with something like this. Within the bucket you choose, you will see all of your exports. So for example, here is a Cyclone DX export I did in advance. This is the bucket that it went to. And you can tell that this export includes 2 different accounts from within my org. And if I were to go even further, I can see, okay, this one account had an EC2 instance. And then finally, here's the raw data. And it's just JSON in a standard format. So you could download it. You can even look at it. But I think it's more powerful to actually use Athena to look at insights across the entire export. And so what I've done is I've created a very simple crawler in AWS Glue to walk through that bucket data. And then that created a data table that I could write then some very simple Athena queries, which at the end of the day are just SQL. So here you can see an example where I just looked at a query that will show me, okay, well for my estate, what's the most common operating systems I'm using? And this is a way to kind of very quickly generate some summary data. In this case, 4 of the resources that were EC2 instances are running Amazon Linux 2. You can see some of the container images are running Debian, and there's another EC2 instance running Ubuntu. Obviously, Lambda functions they're serverless, so there is no underlying OS. As a second example, here you can see what are some of the most common packages that are running within my platform. And here are some of actually this is the platform one, excuse me, wrong one. Here's the top platforms. So here is an example of what are the top packages that are running within my environment. And here you can see add user version 3.118 is one of the most common, and this is running on container images. And then there's our friend Python JWT running on Lambda that we saw earlier that had the vulnerability. All right, I'm going to go ahead and stop it there. We're just about out of time. We had wanted to, could you please go back to the slides? We had wanted to do a Q&A session. I think we ended up going a little longer. So what we will do is, here is our contact information. If you have questions for Brandon and I, you're more than welcome to reach out to us via those addresses, and we'll also be available afterwards, right outside of the ballroom for questions. So that's the end. Thank you very much for attending.